You might have heard, you might have seen, you might have read about quantum safe storage. And quantum safe storage in itself is a very unique proposition. And there's another video that explains that in more detail. What I really want to talk about now is what that physical storage element is that in the end, anywhere on the grid, represents the interface to the physical storage device. So you have a disk sitting somewhere in the 3 nodes, enabled and exposed by a 0S in a certain location. And it then has a little container which runs a so-called ZDB. And that container is actually connected to the private network, the planetary network, inside your private network, and it is able to receive and send data. And it makes sure that it stores that data on that local physical slice of a connected device, because you don't need to have a reservation for the whole device. On a 4 terabyte disk, you can take a 10 gigabyte slice, or you can take a 100 gigabyte slice, up to you. You can define that. But this little ZDB is able to write and store all the information that gets sent to it, and it's able to retrieve previous data that has been stored on it. But it does it in a very unique way. And the unique way that it does it is it takes principles that are very much blockchain-like. Again, we had talked about this before. A blockchain by definition stores data immutable. So this ZDB also stores data by default immutable. So you write it to disk and then you cannot change it anymore. And it also stores it in a way that it is always append. So you store it like the first piece of data is like entry point number 1 on that particular disk slice. The second piece of data that it needs to store is like the second entry point. The third one, well, you get the gist. But that's how it does that. And by doing so, you simplify how you need to manage at a higher level in a whole storage stack the data very much. Because in theory, you don't have to remember what data is stored where. You just ask the ZDB to find it. If it doesn't have in the storage system cached anywhere, it will go through that whole slice of a disk. It will find the particular key that indicates that this piece of data is the data that you want, and then it will return the data. But also, you cannot actually tell it to delete data, because that's not how it's being devised. This has been devised to store data, and when it's full, you take another ZDB on another disk or on the same disk, and you start writing there. All the way up to the point that you know for sure that a whole ZDB is no longer needed, and all the data stored on it is no longer relevant. And that's where you can let go and erase all of the data on the ZDB. And that might sound like an inefficient way of doing it, but the efficiency gain that it gets you at higher levels in the storage system to actually not have to be precisely remember which part of which object is stored on which disk at which part of the disk, it makes it so much easier. It's almost like you go back to the older days where backups were being made onto tape, and you would manage a tape with a whole set of data on it, and when the retention period was over, you just erase the whole tape. You would never erase a part of the tape. And this is taking those same principles that actually data committed to it is not erasable. And that also means that the reliability of the data being available to you, because there's no human error, nobody can delete certain parts by mistake, it's just not possible, is a lot better and more reliable than any other low-level storage element and storage system that exists out there. It is a lot safer and more reliable.